Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know for the upcoming test on measurement. So measurement involves lengths, areas, and volumes. That's what's going to be on your test. That's what we'll go through, and we'll start with length. So one way that we can calculate the length of a side without actually measuring it is using Pythagoras' theorem. So Pythagoras' theorem only pertains to right-angled triangles, triangles in which the largest angle is 90 degrees. So Pythagoras' theorem says a squared plus b squared equals c squared. Here a and b refer to the two shorter sides. C refers to the hypotenuse. The hypotenuse is always the longer side. It's always facing the right angle. So you use this formula here when you're finding the hypotenuse, and this if you're finding a shorter side. So in this diagram here, we have a right angled triangle. We know two of the side lengths. We can use Pythagoras to find x. X here is the hypotenuse. It's facing the right angle. So I'm going to use this formula up here. It doesn't matter whether I call it x or c or whatever. So here I have that the hypotenuse is the square root of shorter side squared plus shorter side squared. You can put straight in your calculator. Answer is 29. In this triangle here, I'm finding the shorter side. So x is the shorter side. I'm going to use this formula. It doesn't matter whether I call it a or x or whatever. So here x will be equal to the square root of c squared. C always refers to the hypotenuse in these formula. The hypotenuse, the longest side, facing the right angle. So when you're finding the shorter side, you subtract. When you're finding the longer side, you add. So 10 squared minus 7 squared is 51. This is equal to the square root of 51. That's the exact answer. And if you put it on your calculator, you can get an approximate answer of 7.14. So this one here is a little bit harder. Now we have x in more than one spot. We're actually going to use this formula up here. We can't jump to either of these two formula because there are two sides for which we don't know the side length. So Pythagoras' theorem says shorter side squared, so we need brackets, so shorter side squared plus shorter side squared equals longer side squared. We have an equation here with one variable. Let's solve it. So here 3x squared, we need to square the 3 to get 9 as well as the x. 24 squared is just 576. You can put that on your calculator. Now similarly, 5x squared, you have to square the 5 and square the x. So square of 5 is 25. And then square the x. All right, let's solve this equation. So here we have 9x squared and a 25x squared. We're going to get the x to one spot by simply subtracting the one with the lowest coefficient. So we get 576 equals 25 minus 9 is 16x squared. So now we divide each side by 16 because I want to get x by itself, not 16x squared. So I get 36 equals x squared. And now you simply square root both sides. You get x equals 6. All right, let's now look at area. So in order to calculate the areas of shapes, you need on your cheat sheet not only the formula, but a way to identify the shapes. So this shape here is a trapezium. I know because it's a quadrilateral. It has 4 sides, and it has one pair of parallel sides. That's what makes it a trapezium. So you should have on your cheat sheet the area formula for a trapezium. It's h over 2a plus b. So the area of a trapezium is perpendicular height divided by 2, and you multiply it by the sum of the two parallel sides. So you can put that on your calculator, you get 90. Now because the measurements were in meters, your answer will be in meters squared. Area is always units squared. So what does it mean that the area is 90 meters squared? Well, what it means is if we take squares that are 1 meter by 1 meter, 90 such squares would fit inside this shape here. So area is the amount of space inside a two-dimensional shape. All right, this shape here is a rhombus. A rhombus is a type of kite, so we use the area formula for a kite. The area formula is xy over 2. So make sure that if this formula is on your cheat sheet, you have some way of knowing what x and y actually mean. So when you're finding the area of a kite, x and y refer to the two diagonals. So here 1 is 13, 1 is 10. So the area here of this kite, this rhombus, is diagonal times diagonal, x times y, divided by 2. Putting that on calculator, you get 65 because the measurements were in millimeters. Final answer is in millimeters squared. All right, let's look at this triangle here. Now, you probably know that the area of a triangle is base times height divided by 2. You probably knew that in year 7. So this is a harder question because remember that h always means, whenever you see h in a measurement formula, volume, area, whatever, it means the perpendicular height. In this case, we don't have it. The perpendicular height is this height here. Perpendicular means at 90 degrees. We actually need to know this height here in order to find the area. So hopefully you can say, hey, lucky we know Pythagoras because we can actually find this using Pythagoras. Because this is an isosceles triangle, we can divide it into two congruent right-angled triangles. We can divide it into two right-angled triangles that are exactly the same size. So that only works for isosceles or equilateral triangles. So if we divide it into this little right-angled triangle here, we need to know this side here, h. We know that the hypotenuse there is 13. We know that this side here must be half of 10, 5. So using Pythagoras, because we're finding the shorter side, we're going to subtract. It is hypotenuse squared minus shorter side squared. Putting that straight on your calculator, you get h equals 12. So the area of this triangle is base, which is 10, times perpendicular height divided by 2. It'll be 60, and because the measurements were in centimeters, we have centimeters squared. So Pythagoras can actually be very useful for solving problems in area and volume. All right, let's now look at circles. So here we have a circle. So we call this distance around the outside of the circle the circumference, C. So it is essentially the perimeter of the circle. We just don't call it perimeter because technically a circle doesn't have any sides. So the line that goes from one side of the circle to the other through the middle is called the diameter. All of these here cut the circle exactly in half. We call them the diameter. So the radius is the distance from the circumference to the center. It is half the diameter. So the point is, it doesn't matter where you start on the circumference. If you draw a line to the center, the length will always be the same. This and this will have the same length. Same for diameter. This line and this line have the same length as long as they go through the center. Now we need to know what they are because we need diameter and radius to find the circumference of a circle. So the circumference is 2 pi times radius. Now pi is just a number. Okay, it's a very weird number. It's 3.14159. It's irrational, so its decimal expansion goes forever. But it's a number that you can bring up on your calculator. So let's say I have a circle like this. So I've got a circle and its diameter is 10 centimeters. So that means its radius will be exactly half that. It'll be 5 centimeters. Let's find the circumference and the area of this circle. So the circumference is 2 times pi times radius. You can put that on your calculator. You get a weird number. To 2 decimal places, 31.42 centimeters. That is the distance around the outside of this circle. What is the area of this circle? Well, the area of a circle is pi times radius squared. So again, put that on your calculator, 78.54 and centimeters squared. Note that the circumference is a distance, it's a length. That's why it was just normal units, but the area is always in units squared. All right, let's look at composite shapes. So that's when you put one or more shapes together. So to find the area of a composite shape, you'll either be adding together two areas or subtracting one area from the other. So in this diagram, we're asked what percentage is shaded yellow. So what we're going to need to do is find the area that is shaded yellow. Well, the area shaded yellow is what you get when you take the square and you cut out a circle. So the area that's shaded, I'm going to call it AS for area shaded, it's going to be the area of the square. So the area of a square is 4 times 4 or 4 squared, just side length squared, minus now the area of the circle. So what is the area of this circle? Well, we know that the diameter of the circle is 4, so the radius must be half of that. The radius of this circle is 2, so the area of the circle, pi times radius squared. So if you put that on your calculator, the area shaded is approximately 3.4336 centimeters squared. So that's the area that is shaded. So the percentage shaded, we just take how much is shaded divided by the total area. The total area is 4 squared, which is 16. That's the area of the square, and times by 100. Remember, if we're finding a percent, it is always first quantity divides second quantity times 100 and then add a percent sign. So putting that on our calculator, we get about 21.46% of the square is shaded yellow. So it turns out, interestingly, that we would have got the same answer regardless of what the side length is. All right, let's now look at converting units. So let's look at converting units. This first chart here you probably already knew. You probably already knew, for example, there are 10 millimeters in a centimeter. But what trips people up is knowing when to times and when to divide. So this tells you when you're going from a smaller unit like millimeters to a larger unit like centimeters, you divide because there are fewer of the large unit. There are fewer centimeters than millimeters. When you're going from larger to smaller, you times because there are more of the smaller units. So kilometer is larger than a meter. If you're going from kilometer to meters, you must times because there are more meters than kilometers. So let's say I wanted to perform this conversion. I'm essentially asking how many millimeters in 0.4 kilometers. So I'm in kilometers here and I want to go to millimeters. So I would need to times by 1,000 to get to meters, times by 100 times 10. So you go 0.4 times 1,000 times 100 times 10. And the answer you get is 400,000. 0.4 kilometers is the same as 400,000 millimeters. But what about if we want to convert square units? So let's look at this square here. So clearly its area is 1 times 1 meter times 1 meter. It's 1 meter squared. But its length is 100 centimeters because 1 meter is the same as 100 centimeters. So what is the area of this square in centimeters squared? Well, it's 100 times 100. It is actually 10,000 centimeters squared. See, even though there are 100 centimeters in a meter, there are 100 squared or 10,000 square centimeters in a square meter. So what does this mean? It means that if you want to convert square units, you need to also square these conversion factors. So make sure this chart is on your cheat sheet. So for example, if you have 0.3 meters squared and you want to convert to centimeters squared, follow this chart. We're in meters squared, we want to go to centimeters squared, we times by 100 squared. So 0.3 times 100 squared is actually 3,000. 0.3 meters squared is 3,000 centimeters squared. This rule about going from smaller to a larger you divide, that still works when you are converting square units. So here I just have the chart for converting between hectares. A hectare is a square unit. It turns out there are 10,000 or 100 square meters in a hectare. There are 100 hectares in a kilometer. So if you have 40 hectares and you want to go to kilometers squared, we divide by 100. We just take our number 40, divide by 100, we get 0.4. It turns out a kilometre squared is actually a lot bigger than a hectare. And as you probably have guessed, if we want to convert cubic units, these units of volume, we need to cube each of these numbers called the conversion factor. So if you have, for example, 3,000 millimeters cubed, you want to go to centimeters cubed. So we're in millimeters cubed. When I go to centimeters cubed, we need to divide not by 10, but by 10 cubed. So you can just put straight on your calculator 3,000 divided by 10 cubed, and you get 3. 3 centimeters cubed is 3,000 cubic millimeters. Once again, this rule up here still works for cubic units. All right, let's now have a look at volume. So we looked at the volume of a prism. The volume of any prism can be calculated using this formula AH. A is the area of the base and H is the perpendicular height. So what does that mean? Well, this shape here is a prism. Now, I'm sorry, I know I'm a terrible drawer, but what makes this a prism? This triangle here and this triangle here are supposed to be the exact same shape and same size. It has a consistent cross section. It has a shape that's either repeated at the front and the back or top and bottom or whatever. That's what we mean by prism. So when I say the base, it doesn't necessarily mean what's on the bottom. It means the shape that's repeated. This is the base because it's the shape that is repeated. So to find the volume of this triangular prism, I find the area of the base. Well, you know that the area of a triangle is 5 base times perpendicular height 8, and then you divide by 2. So that part here is A. That's the area of the base. When you're finding the volume, you just take that area of the base and you multiply by the height. Now, when we say height, it means perpendicular height. I mean the side that is perpendicular to the base. This is at 90 degrees to the base because prisms are 3-dimensional shapes. So if you put that on your calculator, you get 280. Now, when you're finding volume, it's going to be in cubic units. So this will be 280 meters cubed. So I've put up another chart here. I'm sorry, you're probably sick of conversions by now, but this helps us convert between volume and capacity. So the difference is volume has units like centimeters cubed, meters cubed. It has cubic units. Capacity has units that we typically associate with liquid, milliliters, liters, kiloliters, whatever. So it's a pretty easy conversion. It turns out a meter cubed is 1,000 liters. A meter cubed is actually quite big. So for 280 meters cubed, it will hold 280,000 liters. To go from meters cubed to liters, you simply times by 1,000. So the rule from the previous slide still works. If you're going from a larger to a smaller unit, you always times. All right, let's calculate the volume of this cylinder. Now, a cylinder, though it's technically not a prism, you can still use this formula for a prism. So the area of the base, what's the base? Well, the base is the shape that's repeated, so it's going to be a circle in this one. So the area of the circle, the base, is pi r squared. Now, if the diameter is 12, then the radius is half of that, it's 6. So this here is A. This is the area of the circular base. So to find the volume, I take the area of the base and I times by the perpendicular height. The height of the prism is the side perpendicular to the base. So if you put that on your calculator, you get about 1130.97. Because everything was in centimeters, our final answer will be cubic centimeters. Now, it turns out a cubic centimeter and a milliliter are exactly the same thing. So the capacity of this cylinder is 1130.97 milliliters. Now, if you want to convert that to liters, if you want to go milliliters to liters, you divide by 1,000. So if you put on your calculator 1130.97 divided by 1,000, you get about 1.13 liters. All right, one more thing to go through, and that's finding unknown sides. So here we're going to look at finding unknown sides when you know the area or volume of a shape. So always follow these steps. Write the formula, substitute, and then solve. So hopefully those steps will become clearer after we do an example. So let's say the area of a circle is exactly 484 pi centimetre squared. What does that mean? Well, 484 pi is just a number. Were you to put it in your calculator, you get about 1520.53. So I'm just saying the circle has area 1520.53 centimeters squared. This is just the exact number. This is a rounded number. So we're going to calculate the circumference when we know the area. So what you should first ask yourself is, what do I need to know the circumference? Well, the circumference of a circle is 2 pi r. So I can't calculate the circumference unless I know the radius. So what I'm going to do is I'm going to use the area that I'm given here to find the radius. How do I do that? Well, we start by writing the formula. The area of a circle is pi r squared. Now what I'm going to do is substitute into this formula everything I know. Well, all I know is that the area of the circle is 484 pi. So I'm going to get rid of a and substitute it, replace it with 484 pi. So now I'm up to the third step, which is to solve. So because there's a pi on both sides, I can cancel it out. I'm dividing each side by pi. I have 484 equals r squared. So I can simply square root the left-hand side as long as I also do it to the right-hand side. What you do to one side, you must do to the other. So square root of 484 is actually 22. I have found the radius of this circle is 22. So its circumference is just 2 times pi times radius, and you can put that straight in your calculator. You get about 138.23, and it will be in centimeters because this was centimeters squared. All right, let's calculate the value of x in this diagram here. We're told the area is 112 square units. So this is a composite shape. So the area is the area of the rectangle plus the triangle. So let's write a formula for the area here. So the area of the rectangle is length times width. And then the area of the triangle is base times height over 2. That'll give me the area of the total shape. So let's go and substitute. So let's look at the rectangle here. Well, here the width is x plus 1 and the length is 12. So what I'm going to do is I am going to rub out length and width. I'm going to replace the length with 12 and the width with x plus 1. So let's now turn our attention to the triangle. So the base of the triangle is x. So I am going to replace the base b with x. The perpendicular height is 8. So I replaced h with 8. Now I'm told that the area is 112, so I'm going to replace a area with 112. I now have an equation that I can solve. So I'm going to first expand the brackets. So 12 times x and then 12 times 1. Now, for this next part, x times 8 over 2. Well, 8 divided by 2 is just 4. So this here is just 4x. It's starting to look a lot more like an equation we can easily solve. So now what I'm going to do is add 12x and 4x. They are like terms. So I get 112 is equal to 16x plus 12. So to solve this equation, we've solved ones like this a million times. Subtract 12 from both sides and then divide each side by 16. So my final answer here is x equals 6.25, and I'm done. All right, thank you so much for tuning into this video. Best of luck studying, but you'll ace the test. You are a star. This has been the luckiest maths teacher in the world. Have a great day.